Hello again. I want to take up some of the homework from our last day. We were doing 5.3 and 5.4 together. Today I want to take up a little bit of the homework that we were doing. So I'm going to start us off on a clean sheet, and I'm going to take up a little bit of the homework. Now, I'm not sure that I actually assigned questions 6 to 9, but I'm going to look at questions 6 to 9 on page 179. Now, if you haven't done these yet, because I didn't assign them, I'm going to encourage you to go back and try them. Now, if I look at, so let me say 7 to 9. If I look at question 7, it's asking what the molar mass is for the following elements. So the molar mass, this is question 7a, right? It's asking for the molar mass, big M, for helium. And all I need to do is look at my periodic table, and it's 4.00 grams per mole. Right? B says, what is the molar mass for manganese? Molar mass for manganese. Again, I'm going to open my periodic table here, have a quick look. It says 54.94 grams per mole. Right, so you can see that the molar masses is exactly what it says. It is the mass of 1 mole in grams. So if I have manganese, if I went to the stock bottle and picked up the bottle that says manganese and I poured out 54.94 grams, you would have exactly 1 mole. You would have 6.02 times 10 to the 23rd atoms. If I went to the cylinder and weighed out 4 grams of helium gas, right, 4 grams, right, it would be equal to 1 mole. I would have 6.02 times 10 to the 23rd atoms of helium in that sample. All right, so that is the molar mass, the mass of 1 mole. If I look down to question 9, oops. And I look at A, and it says calculate the molar mass for these elements. What is the molar mass for nitrogen gas? Now again, remember, nitrogen is one of those 7 elements, right? Han and the halogens, H2O2, N2, and the halogens. Right? So remember, there's no N's in the world. There is manganese in the world, there are helium atoms in the world, but nitrogen atoms don't exist in the world. They only exist as an element as N2. Right? O is O2, H is H2. Right? Helium is just He. Okay, so if I ask you for the molar mass for nitrogen, I now need to look at my periodic table. Periodic table says nitrogen is 14.01. Oh, but there are 2 nitrogen atoms. So the molar mass is going to be 2 times the molar mass for nitrogen, which is 28.02 grams per mole. Right? So you can see that now what I have is a mole of nitrogen molecules. Right? No nitrogen atoms, because nitrogen atoms don't exist on their own. I have nitrogen molecules. The same thing if I look at 9C. If I look at 9C, right, it's asking for the molar mass of chlorine gas. Okay, remember, chlorine is another one of the 7 elements, right, and it exists as Cl2 on Earth. Right? So, to find the molar mass for chlorine, I open up my periodic table. It tells me chlorine is 35.45. So I need to have 2 because there are 2 chlorines. 35.45s, which is 70.90 grams per mole. Okay, so there's 9C. Okay, so that's telling me the mass of 1 mole of chlorine molecules, Cl2s. Now, in yesterday's homework, I asked you to calculate question practice problem 8 from page 180. Okay. Part A says calculate the molar mass for the following. What is the molar mass for carbon monoxide? Notice it's not cobalt, it's carbon monoxide, CO. So, I need to have the molar mass of carbon plus the molar mass of oxygen. 12.01 on the periodic table plus 16.00, right, which is the molar mass for oxygen, which gives me a molar mass of 28.01 grams per mole. That is the molar mass for carbon monoxide. So if I gave you 28.01 grams of carbon monoxide gas, you would have exactly 6.02 times 10 to the 23rd COs floating around in there. That is a mole of carbon monoxide. Okay, I'm hoping you're getting the idea here that there's a recurring theme that we're talking about this idea of a mole, right? And how much mass does that mole have, right? Using the molar masses from the periodic table. Okay, 8C says calculate the molar mass for magnesium hydroxide. Okay, magnesium is a +2, hydroxide is a -1. So the -1 comes to magnesium, the 2 goes down to hydroxide. So that's magnesium hydroxide, MgOH2. If I want to find the molar mass, it's going to be molar mass of magnesium, and there's only one of them. Right, there's one magnesium. I see that there are 2 OHs there, which means I have 2 O's and 2 H's. So I need twice the molar mass of oxygen and twice the molar mass of hydrogen. Okay, notice it's not H2, it's just the molar mass for the element hydrogen, because I'm not talking H2s here, I've got OHs. Right, the oxygen is bound to hydrogen. So if I go back to my periodic table now, I can look up the molar mass for magnesium. It is 24.31 plus twice the molar mass of oxygen, 16.00, plus twice the molar mass of hydrogen, 1.01. And I end up with I better do the math here. 58.33 grams per mole. Right? So again, if I went to my bottle of MgOH2, which I've got 2 bottles of actually in my storage room, and I gave you 58.33 grams, you know that you have exactly a mole of magnesium hydroxide, of MgOH2. Okay, so get the idea here now that I can calculate the molar mass for any element or for any compound just by going to the numbers on the periodic table that we've called relative atomic masses. Well, they're also molar masses. All right, so those numbers that we've been using for the last couple of weeks before the break, where we say hydrogen is 1.01, helium is 4.00, lithium is 6.94. We talked about what those numbers meant as an average mass for that element, for atoms of that element. Now we know that it also represents the mass for 1 mole. And that's how come, again, in that note that we just finished yesterday, in the note we finished yesterday, I started with why this number, right? Why this number, right? And it's, right, that is a mole. So that's the number that allows us to figure out from the masses on the periodic table how many atoms or molecules do I have. Okay, so today what I want to do is I want to move beyond where we were, and I want to look at how to make how to do calculations using this molar mass. Now, what I know is in a chemical reaction, in a lot of cases we've balanced our equation, so we know how many atoms of each there are. We also know how many moles there are. We talked about this the other day in class, where we said if I've got a reaction that says sodium reacts with water and our products are NaOH plus H2, right? And if I have to balance this, if I put a 2 in front of sodium and a 2 in front of sodium hydroxide and a 2 in front of water, I now have, let me just see, I have 2 sodiums and 2 sodiums. I have 4 hydrogens, and I have 2 and 2 is 4 hydrogens, and I have 2 oxygens. Okay, so I am balanced. Let's do it to my dots. I know that I'm balanced. Now what this tells me, and again we know this, that if I want this reaction to happen, I know that 2 atoms of sodium will always react with 2 molecules of H2O to make 2 molecules of NaOH and a molecule of H2 gas. Right? We've balanced equations for quite a while now, and that's why we're balancing our equations, to figure out how many atoms and molecules are needed. But we also said that if I make this happen a lot of times, it will always happen in a ratio of 2 to 2 to 2 to 1. So if I start with, instead of 2 atoms of sodium, if I start with 2 moles of sodium and 2 moles of water, I will make 2 moles of NaOH and 1 mole of H2 gas. Right? Now that I know that, I can say, oh, 2 moles. Well, I know how much that weighs, right? 2 moles is 2 times the molar mass of sodium. Right, 2 moles. So I want to actually figure out how much does 1 mole of sodium weigh? Well, I know what that is. It's on the periodic table. It is 22.99 grams is 1 mole. So 2 moles would be twice as much. And the same thing, if I can calculate what H2O is, it's 2 hydrogens and an oxygen, which makes it 18.02 grams per mole. Oh, but I have 2 moles, so I guess I just have to multiply that number times 2 to come up with the answer. So we've come up with a way to make this work using a formula, which is again on your periodic table. Right, there's the formula right there. Okay, and again, we're going to use this formula. I can't even tell you how many times in the next 3 months you're going to use this little formula that says M equals N times big M. M is going to be the mass of the chemical, right? The mass of the chemical, which is measured in grams. I'm actually going to weigh it out on a scale. Big M is the molar mass. It comes from the periodic table, right? We just look on the periodic table for that chemical and we find out what its molar mass is. And little n tells me how many moles there are in my equation. So if I know I need 2 moles, then I can figure out how many grams there are. If I need 19 moles or 0.46 moles or whatever the answer is, I can quickly calculate how many grams I need or I'm going to make. So the sample problem here says a student is doing a lab and they need 2 moles of calcium nitrate to do the lab. Right? It says how many grams does the person need. Okay, so if I go back, okay, and it says the person needs 2 moles of calcium nitrate. Two moles of calcium nitrate. Okay, so let's scroll up a little bit here. So if I need 2 moles of calcium nitrate, it says how much mass do I need to weigh out? So what I'm given here is the sample. That's on sample 4, which is on page 181 of our textbook. Okay, and on that question, they're going to do the same thing that I'm doing here. So I'm going to walk you through it. It It says, so the person needs 2 moles, and what is the mass? So what am I given? I'm given the number of moles of calcium nitrate, and I'm required to find little m, the mass. Now, my formula for this, right, is the formula that's on your periodic table. Actually, I'm going to pull it up for you. I can't remember where it is on a periodic table. I haven't got one home with me here, but you'll see it's on your periodic table. I think it's at the bottom of the page, and the formula says little n is equal to little m times, little m, my approach, mass equals number of moles times molar mass. Think, okay, so I know I'm trying to solve for little m here. I know my little n. What about big M? Well, I got to solve big M before I can do anything. But we know how to solve big M because we've just been doing that. If I want to solve for big M, for calcium nitrate, it's 1 times the mass of calcium plus it's NO3 times 2, so it's 2 nitrogens, 2 molar masses of nitrogen, plus, and it's NO3 too, so there's 3 times 2, 6 molar masses of oxygen. So I'm going to put my numbers in here. Calcium is 40.08 plus 2 nitrogens, 14.01 plus 6 oxygens, 16.00, and my molar mass comes out to be 164.10 grams per mole. So I now know big M. So now I can work through my formula here because I know big M, I just calculated it. Little n was in the question, and little m here is my unknown, m equals. Okay, so now I'm actually gonna solve it now. So let's scroll up a little bit more here. Okay, if I'm going to solve it, I'm going to substitute mass is equal to the number of moles. Well, that's in the question up at the top. Oops. Okay, that's in the question up at the top here. Okay, my number of moles times the molar mass. Molar mass is 164.10, and I end up with a final answer of 328.20 grams. Little m, mass, in grams. Okay, so my phrase, therefore, we need 328.20 grams. Okay, so there is a sample problem converting how many grams do we have or need if we know how many moles. We can go the other way around too. All right, so I'm going to look at sample problem 5, which is also in the textbook. Okay, sample problem 5 is the same one here that I have in the textbook. It says calculate the number of moles of sodium chlorite, ClO2 this time, in a water purification tablet that has a mass of 2.56 times 10 to the minus 2 grams. Okay, so my wife and I do a lot of camping in the summer. Sometimes we don't go to a campground, we just go into the woods. And we'll disappear for 4 or 5 or 6 days with our canoe and our tent and dry food. And the one thing that we need to survive is water. Now, water's heavy. I'm already walking into the forest, paddling down a lake, then lifting up my canoe and my tent and my sleeping bags and my clothes and everything else and carrying it through the forest to the next lake where I'm going to paddle down that lake, and maybe I'll put my tent up in that next lake. But I don't want to have to carry that water with me if I'm paddling through water. So I just get my water from the lake. Right? But there's a problem with that, and in that sometimes the water in the lakes isn't clean and pure. So I take one of these tablets of sodium chloride and I drop it into my water bottle. I wait 30 minutes and then the water is good to drink. I know even if the water in the lake was dangerous, that pill will clean it up for me. Now it tells me that the pill has a mass of 2.56 times 10 to the minus 2 grams, or 25.6 milligrams. Okay, now, the question is, how many moles of the chemical are actually in that pill? Okay, how many moles? How many moles? So let's go back and let's work on sample 5 here. I feel like I'm learning how to write here. My writing is so messy on this iPad. Okay, so sample problem 5 on page 182. Okay, so we're told, what are we given? We're given the mass of my tablet, 2.56 times 10 to the negative 2 grams. There's the mass. And the question is asking me, how many moles are in that tablet? Now, to solve for little n, again, remember my formula from up here. Formula says mass equals number of moles times the molar mass. So I'm going to come back down here. Mass equals number of moles times molar mass. Mass equals number of moles times big M. If I want to solve for little n equals, right, so I'm looking for here, n equals, I need to take the big M from here down to the denominator on this side under the little m. So little n now will be little m over big M. Little n equals mass divided by molar mass. Little m over big M. Now, to do that though, I already know the mass. The mass was given in the question, right? The mass is up here, right? But I don't know little m. Big M, sorry. I know little m, but I don't know big M yet. I can always find out big M though, because I've always got a periodic table around. So the molar mass now, the chemical is NaClO2. ClO2. Now, so if I want to find the molar mass, I need to have 1 molar mass of Na. There's a chlorine in there, a molar mass of chlorine, and there are 2 oxygens. Molar mass of, 2 molar masses of oxygen. Back on my periodic table, molar mass for sodium, 22.99. Molar mass for chlorine, 35.45. And 2 molar masses for oxygen. Oxygen is 16.00. And I get a molar mass of 90.44 grams per mole. So now I know my big M for the formula up here. So now I can go ahead and I can solve my problem. Okay, the problem was, what is little n? Right, little n is equal to, so let's substitute in, little n is equal to little m over big M. The little m was 2.56 times 10 to the negative 2 divided by big M, which is 90.44. And my answer turns out to be 2.83 times 10 to the power of negative 4 moles. Okay, and that's my answer. Right, 2.83 times 10 to the minus 4 moles. So when I take one of those tablets, okay, out in the bush, that's how many moles of chemical I am getting. So phrase, therefore, one tablet has 2.83 times 10 to the power of negative 4 moles of NaClO2. Done. Okay, so that is our strategy for solving these problems. And I'm going to stop there for now. I'm going to ask you to work on these questions here on page 182, 11, 12, 13, and 14. And I will come back. I will take some of this up in the next note, and then I want to move on to doing one more calculation before we're done this section of Chapter 5. All right, so I hope you're doing well, and good luck with this work. Again, if you get stuck at all, always go ahead and ask a question. If you leave a question in the discussion forum, send me a quick note in Remind. I seem to be checking it at least once an hour, if not more times an hour. So if you post something for me to find there, I will probably find it. All right, and I will answer it for